Hey guys, this lesson is specifically for Calculus BC. So if you're watching this playlist, you're watching a chapter that is only for Calculus BC, okay? So this is 8.1. This technically isn't anything new. This is just a quick recap on integration and reviewing lookalikes. I'll do 3 examples and then we'll move on in the next video to the actual BC content. One of the trickiest things in the AP test is that when you see the integration of a fraction function, a rational function, is that they look so much alike you don't know which rule to pick, okay? So this first one, remember you're asking yourself, do I see the derivative of this denominator on the top? Well, no, I would need at least a variable of x there, and I don't have that. Hopefully your eyes start to catch that this looks like arctangent, okay? A reminder that arctangent is the integral of 1 over x squared plus a squared dx, okay? So in this question, right, I have the x squared plus, that means that my a is going to be 3, right? Because 3 squared makes 9. So actually, you might even be used to seeing that with a u squared instead of an x squared. Let's write that how you see that in that formula sheet, okay? So let's say u squared. So that means that my u would just be x, because u squared would make the x squared. And then my a is going to be 3. And then I can take this 4, coefficient of 4, and bring it to the front so that I have that coefficient of 1 up in the numerator here. Okay? So now I'm going to just rewrite this as 1 over x squared plus 3 squared. It might be a little easier to see. And now I can go ahead and write the antiderivative. I'm going to write the coefficient of 4 up front. And now the rule for arctangent is 1 over a, right? So I have times 1 over 3. And then arctan of u over a. So now here I have arctan of u, which is x, over a, which is 3, and then plus c. So just clean this up a little bit. We'll say 4 over 3 arctan of x over 3, or 1/3 x, plus c, and we are done with this one. For my next question, again, we kind of mentioned this on the first one. One of my first go-tos, guys, is always going to be u sub. The fact that in my denominator, the derivative of an x squared would be a 2x, and here I have a 4x, and then derivative of 9 disappears, makes me want to use u sub, okay? So if my u is x squared plus 9, the more complicated one, a u prime should be 2x, and derivative of 9 is 0. So I don't have a 2x, I have a 4x. There are different ways of doing this. You can figure out what the difference of what you would need is. I personally like to take out the number that's there and put it out front. Put the 2 that I need and then multiply by that reciprocal of half. Okay? So when I rewrite this, okay, I have the 4 times the half is just a 2. Integral, right? I'm going to rewrite it very slow for you guys, and then I'll keep going. So now I have 2 times 2 is 4, which is what the original question says. I'm okay. But now I wrote it in a way where I can see the u prime on the top and the u in the bottom. So now this becomes 2 times the integral of u prime over u. Okay, so this is an ln question. I could say 2 times ln of absolute value of u plus c. And now just go ahead and plug that u back in. Oops. So I have 2 ln absolute value of x squared plus 9 plus c. And x squared plus 9 will always be positive. So technically, if it was a multiple choice, you wouldn't need that absolute value bar, you could just put it in parentheses, and I'm done with this one. And now for my last question. If you have your rules memorized down pat, guys, and it really all comes down to that, hopefully the first thing your eyes catch is that both the numerator and the denominator are squared. Okay, we said whenever the numerator's exponent was greater or equal to, I have to do long division. Okay, so my denominator goes on the outside of that box, and my numerator goes on the inside, 4x squared. Okay, now I don't have anything else after that x squared, but that's okay. Just know that if I did end up having to multiply by an x to the first, I'd put it over here, or by a constant over here. Okay, so remember, when I'm doing long division, I'm really just looking at these first terms. What do I need to multiply x squared to get a 4x squared? Well, I only need to multiply a 4. Okay, so I'm going to do it on the side. 4 times x squared plus 9 is going to give me a 4x squared plus 36. Okay, so I have 4x squared and a positive 36. Remember, when we're doing long division, now we subtract this. So pretend like there was a 0 here. Okay, so 4x squared minus 4x squared is 0. And 0 minus a 36 gives me a negative 36. So that's my remainder. My answer would be 4, instead of plus, because my remainder is negative, I'm going to put minus 36 over what I was dividing by, which is x squared plus 9. So now this is what I'm really doing my integral of. Okay, I'm going to bring this up here, and I'm going to split it. I'm going to say the integral of 4 dx minus, I'm going to bring that 36 to the front. I know this isn't going to work as a u sub, okay, because if it was u sub, I would need at least an x up there. So I'm going to take out that 36 and say the integral of 1 over x squared plus 9. Okay, now this looks like the first question we did, and we can catch that this is arctan. Antiderivative of 4 is going to be 4x minus 36. And now the arctan rule, which is going to give us 1 over, we know that according to our first question, our u is x and our a is going to be 3. So I'm going to have 1 over a, which is going to be 3, arctan of u over a, which is going to be x over 3, and then plus c. If I clean that up a little bit, I have 4x minus 36 divided by 3 is going to be 12. Arctan of x over 3 plus c. And we are done with this one.